Okay, so this is the review of the Year 11 trial exam for 2026. So this is paper 1, and the first question is all about dam. Alright, and it asks you to calculate the total pressure at the bottom of the reservoir. Now, straight away, I'm just going to highlight that for you. Okay, it's the total pressure that they're after. Whoops, hold on, it's the total pressure that they're after. So if you can't remember the formula that links pressure and depth and gravitational field strength, you can look it up in the data booklet. It's under section 5, which is solids, liquids and gases, and there it is. Okay, so let's write it down. I'm going to write it down in symbols. The change in pressure is equal to rho g delta H, which is the change in depth. So the change in pressure is equal to the density, which is 1,000, times by g. Now that's actually given to you on the previous page. Look, you can see where necessary, assume that the acceleration due to freefall g is 10 meters per second squared, or 10 newtons per kilogram. So g is just 10, and then the height is 35. Okay, so the change in pressure is 35,000 pascals. All right, but okay, let's go back to the formula booklet. Look, you can see that this is the important bit. This is the change in pressure, right? Whereas the question is asking you for the total pressure. So what we've just found out is that the pressure due to this water column is the 350 kilopascals. Okay, but you've also got an additional 100 kilopascals from the pressure at the surface. Okay, so to find the total pressure, you've got to add those two together. Okay, so the total pressure is 450 kilopascals. So underwater camera is used in the water reservoir, and that's given us a force and a pressure, and it's asking us to calculate the area. So hopefully a formula is jumping off the page at you already. If it's not, then you just need to go and have a look in the formula booklet. Pressure equals force over area. That's the formula before, right? So P equals F over A. Then I need to rearrange that so the area is the subject. Okay, you can use the formula triangle to help you to do this if you wish. F up there, P over there, put my thumb over A, and you can see that that's force divided by pressure. Okay, now there's a bit of a sneaky bit here, because look, that pressure is in kilopascals, right? So 430 newtons, we don't need to convert that, but because that's in kilopascals, we've got to multiply by 1,000 to get it into pascals. If you work that out on your calculator, you will get 1.6538 blah 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 times by 10 to the minus 3. Okay, and then to decide how many significant figures we've got to give our answer to, then we're going to look back at the question. Okay, that's to 3 significant figures, that's to 3 significant figures, so it makes sense to me to give my answer to 3 significant figures, which is 1.65 times 10 to the minus 3. Note that it's absolutely fine to use standard form when writing out your answers. That's no problem at all. Okay, and now the units of area in this formula are meters squared. Okay, and if you're not sure why, I can prove it to you. The units of force are newtons, the units of area are pascals. Okay, but a pascal is a newton per meter squared. Okay, so if you cancel the newtons with the newtons and bring the meter squared up to the top, then that gives you the correct units of meter squared. Okay, seawater's got this density. Explain how the design of the dam would need to be changed to hold the same depth of seawater safely. Okay, so it's asking for an explanation, and we've got to link this back to the design of the dam, right? Okay, so the first thing to do is to go back and have another look at that formula. So delta P equals rho G delta H. So if density changed, then what happened to this number here? That number increased, right? That number increased. It's on the same planet, so that number there is constant. Okay, and you know, it's same depth, right? So that number there is also constant. So that means on the right hand side of the equation only one number increases, and that's the density. But that does mean that the pressure at the bottom of the dam is going to need to increase. Okay, so what effect is that going to have on the design of the dam? Do we need to make the dam higher? No, because it's the same depth of water. But now at the bottom of the dam down here, you've got a greater pressure. So how are you going to change the design of the dam to compensate for that? You can give it thicker walls at the bottom. Okay. Why do they need thicker walls? Because the density increased, which meant that the pressure at the bottom of the dam increased. Okay. And that is the end of question 1.